record. And let's see, I'm gonna share my screen. Okay, yes, so 2 monitor setup now, so I have to choose wisely. Okay, desktop one, got it. Cool. So is everyone able to see my screen?
Yep.
Excellent. So I'm going to the ChanR-Community here, and actually I'm going to create a new repository, and this will go under ChanR-Community, and this is going to be called, we'll call it the Python DS ecosystem pandas 1. All right, and I'll keep it private for now, but after I make some updates, I'll turn it so it's public. All right, so creating that. All right, so I'm going to upload the Google Colab notebook to this repository at the end of the session. So right now it's just there as a placeholder, but I'll update this, add some notes with some of the things that we discussed, and then I'll make it available to everyone. So if you join the Discord channel, which is this one here, let's say under this channel where it says meetup recordings, I'm going to add the recordings or the recording for this session, as well as the GitHub repository when it's public. So that's when you'll be able to get all the contents. I try to go the extra mile for all. So yeah. Okay, so now that we got that out of the way, let's go ahead and get started. So let's see. So we're going to be talking about the foundations of pandas. So we're going to discuss 2 important data structures. One of them is called a series object, and another one is called a data frame. So let's open a sketchpad, and I'll explain what they are conceptually. All right, so let me just hit the new button here. Oops. And all right, so over here, let's say that you have some information in a data set. So let's say that this data set could be in a file, like maybe like a CSV or a comma separated values file. Maybe it could be in an Excel sheet. Perhaps it could be coming from a database. So all kinds of different data sources. So the thing is, the information that you get usually has some kind of structure to it, most of the time. So that structure could be what we call as like a one-to-one relationship. Sometimes it could be a one-to-many relationship. And the way that we most commonly represent data is through this idea of a table. So inside of a table, you essentially have what we call as a 2-dimensional view of data. The 2 dimensions happen to be the number of rows and the number of columns. And so what pandas does in Python is it allows us to have a way to represent data 2-dimensionally and in a very easy to understand manner. In fact, it's not the only module that allows us to do this. In fact, there are plenty of other modules that could be used to replicate the same purpose. In fact, in a very bare bones Python manner, if any of you are familiar with the Python list, you can also represent data 2-dimensionally by having multiple lists inside of a bigger list. And that would still be considered as 2-dimensional data. But what makes pandas really stand out is it's more interpretable. Instead of trying to look at brackets after brackets, you're actually looking at information as various rows and columns. So it's really good for people who interact with data in a very common way, which is like maybe through Excel sheets or maybe through reports, like where you actually see things in this tabular way. So if we could have this kind of structure in Python, then you'll feel more comfortable with it. It'll feel less complex, and at the same time, you'll feel excited with what's possible. And so today we're going to go over 2 important structures with pandas with this table-like view. So one of them is called a series, and the other is called a data frame. So let's start with a series. So the simplest way that I can explain a series object to you is anything in the data set which you could represent in one dimension. So this could be a row or it could be a column. That's the best way to describe it. Most people in other boot camps usually think of it as just a column. But the reason I don't do that is because you could also represent a row as a series object. And in fact, I'm going to show you an example in Google Colab to prove that point. So let's go ahead and go on Google Chrome. And on a new tab in your browser, go ahead and just type in Google Colab. And you'll see this link here that says collab.research.google.com. Go ahead and click on this link, and it will open something like this. If you don't have this exact view, you might have something that looks like this. And if you do, then what you should do is go to where it says File, and you'll see a button that says New Notebook. Go ahead and click that, and you'll see that a interactive Jupyter-like looking notebook opens up. It might have Untitled with a number after it. For me, it's Untitled 16, but the number might differ for you. But that doesn't really matter. What matters is that we're able to open something like this. Now, one important thing to remember about this is that since this is a Google product, you have to be signed in with a Gmail account in order to use this. So does anyone have any trouble opening this notebook? If so, and I would be happy to help resolve that. So are we all able to open this? Excellent. All right, Kathy, how about you? Good, very nice. Okay, so since everyone's able to open this, let's go ahead and get started. So the first thing we're going to do is where it says untitled16.ipynb, just go ahead and put your cursor on the left side of the period, which stands for the starting of the file extension. So as if any of you have worked with Jupyter notebooks in the past, then one thing you will know about this file extension is that it stands for Interactive Python Notebook. So all we're essentially doing is we're just renaming the name of the notebook. So that's why we only highlight whatever's on the left of the extension. So in this case, where it says Untitled 16, let's go ahead and call this as pandas. You could do like a Roman numeral 1. You could also put the number 1 if you want, but I'm just going to go with the Roman numeral 1 here, which is just a capital I in this case. So just go ahead and hit enter, and this will now be known as pandas1.ipynb. So now that we have that, what I'm going to do now is I'm going to create a little structure to this notebook. So before going straight into code, I like to have some kind of a markdown cell that describes, what the following code is going to be about. That way, it's really understandable to people who might be looking at your notebook, or even just for you, like if you want to review what you learned, it could be a fantastic tool to really help you keep track of everything. And in fact, that's the intended purpose behind Jupyter, right? It's supposed to be a notebook just as much as it is a way to write code. So let's definitely, keep that strategy in mind. So the way we can do that is we just hover over where it says plus text, and this will create what we call as a text cell, but in fact, it's a markdown cell. So if no one here is familiar with Markdown, Markdown is a format that allows you to write text directly to the web. So you can think of it as like an alternative to HTML. But it supports like standard text and all the different like formats that are there in HTML, like the different headers and whatnot. So all those things are there, and it's very interactive. You can also put links and also images and things like that. So it's a pretty cool thing. And in fact, we'll take a look at that now. So if you want to make like a nice title like text, you can put like 1 or 2 hashtags, and you can get like a really large text here. And you can see the preview of it on the right side. So let's say after the hashtag, let's say that you type in series. You'll see that you get a really large looking series now. It's because of the 2 hashtags. And so let's say that we just hold shift and press enter on that. Now this cell is only going to show you the preview. So what we're going to do is we're going to move this up. So the way we do that is you'll see that there's a little menu on the right side of this. So the first option that has the arrow that's pointing upwards will move this cell just 1 row upwards. So now that we have this at the very top, we can now click on this cell that we have on the bottom. So this cell here, this is a code cell. So this is where we can write actual Python code, which we can execute. So in here, the first thing we're going to do is we're going to create what we call as import statements. We need to get pandas as well as any other library that we might be using. So luckily for us, Google is generous enough that in each of these networks, not networks, but notebooks, they're actually connected to what we call as a Google Cloud instance. So that means that there's a virtual computer where all of this is being hosted. And in that virtual computer, we have access to a version of Python 3, as well as a lot of the common data science packages that are used in Python. So that includes pandas, as well as some other popular ones like numpy, matplotlib, and etc. But that's really good news for us because we don't have to install anything. We can just get straight to the coding part. So in order to do that, you just have to write your import statements as you would. So you can say import numpy as MP. So this would allow us to import numpy. And we're also going to import pandas. So we're going to say import pandas as PD. And if anyone's wondering what this as here means, this is basically what we call as an alias. So instead of just importing numpy with just the word numpy, we're now creating a shorthand notation for it. So whenever we actually use the package, instead of saying like numpy with whatever method is there, we're just saying mp dot whatever method is there. And similarly, we're doing a very same variation with pandas. So we can say like pd.series instead of pandas.series. But it's a nice way to just make things look a little more nicer when it comes to the typing. All right, so that's what that's there for. So now let's go ahead and click this play button, and you'll see over here that's going to connect to an instance. So once it initializes, you'll see that you get this view here where you have a bar for RAM as well as for the disk. And if you hover over it, you can see it tells you that it's connected to the Python 3 Google Compute Engine backend. And it tells you that you have 12.69 gigabytes of RAM, as well as 107.77 gigabytes for storage on the disk. So all of this is available to you free of charge from Google. So I just wanted to make sure that you're all familiar with that. And with Collab, there's also a lot of other things that Google provides to you, but we'll discuss that on a later date. So now let's get straight to the pandas. Okay, so over here, now that we created our imports, let's create just a set of random numbers that we could visualize as a pandas series. So I'm going to do it in 2 different ways. I'm going to do it in one way where we are essentially trying to create random numbers in a list in Python. And the second way that I'm going to do it is using a nice method in NumPy. So that way you can see 2 variations of the same problem. All right, so in version 1, what we're going to, and by the way, this is creating a comment in Python for those who might be less familiar with it. So I just wanted to make sure that you all know that you always put a hashtag to reference a comment. Okay, so for version 1, we are going to do this using a module called random. So actually, we should also import random. So that way we'll be able to use it. So you can say import random, just like that. And you can rerun that cell by just clicking the play button. And over here in version 1, we'll say creating random numbers in a list. So to do this, we are essentially going to create an empty list. So we'll call it as random numbers. So you're just going to assign it to an empty list like this. And just to make things a little bit more understandable here, I'm also going to add some comments for each of these, so it's very clear to everyone why we're doing this. So we're going to say initialize an empty Python list. So that's what this is for. And one thing I just want to quickly let you know about the way I create comments is I use one hashtag for what the entire block is about, and I use two hashtags for what each individual line is about. That's how I define my comments in Python. So I just want to make sure you're all familiar with the way I do that, so then it won't be a mystery as to why I'm doing that. Okay, so now let's go on to the next part, where create a for loop in order to pass in random numbers in a given range into the empty list. So the way that we can set that part up is like this, where we're going to create a for loop where we can use a temporary variable like I. So we can say for I in, and the way that we can go through a bunch of numbers in a sequence in Python is using something called range. And within range, we just have to specify some kind of number sequence. So in this case, let's say you want to have 1,000 random numbers inside this for loop. You can just put 1,000 there. And this range is essentially putting the numbers 0 all the way to 999 as what I is going through. That's what this indicates. So what we're going to be doing now is, instead of putting those numbers, we're going to tell Python to use the random module to spit out a random number between 0 and 100 for every single one of these numbers from 0 all the way to 999. So that way you will end up with 1,000 random numbers. So we'll call this as num as a variable. And we're essentially going to use the random module. And the method that we're going to be using is called randint. So randint creates a random integer. So all we have to do now is specify the bounds, like which numbers should it be between. And both of those bounds are included, by the way. So let's say that if you put A as 0 and B as 100, 0 and 100 could also be random numbers that could be as an output from this method. So let's say you put 0, 100. So all we have to do now is add this variable every time it goes into the loop inside of this list. So that's very easy to do in Python. We can just say random numbers dot append, and you just have to pass in this variable called num. So once you do that, now once this executes, you'll be able to see all the random numbers between 0 and 100 showing up with 1,000 different numbers in that range inside this list. So the way we could see that is we can just print the resulting list. So we'll just say print random numbers, just like this. And if we go ahead and press the play button, you can see that we get this list here. So this should give you a bunch of random numbers. All right, so is everyone clear with that code? Does everyone have any questions about how I went about this? Excellent. All right, looks good to you. Howard, Kathy, are you both good? Okay, great. So Kathy, you're good. Howard, are you good too? Got an error on num equals random. Oh, it's random.randint. So it's yeah, randint. Okay, did you join the Discord channel? If so, what I could do is I could just paste the code there, so you can just take what I have. Oh, you're good to go. Okay, excellent, excellent, nice. All right, so now that we have this part done, The next thing that we're going to be doing is we're going to convert this list into a pandas series object. So let's go ahead and do that. So the way that we'll set that up is we're going to hit this plus code. So it creates another code cell below the cell that we already created. So what we're going to be doing in this cell is we're going to convert the random list into a pandas series object. All right, let me just check the chat real quick. Oh, excellent. Thank you so much for mentioning that. All right. All right, so convert the random list into a pandas series object. So, oh, right. And just to keep things consistent, I'm going to use one hashtag. Yeah. And then over here, all we need to do is in one line of code, we just create a variable. So we initialize a pandas series with the random numbers list as the input. So basically what that means is, let's say you create a variable called random series like this. All you have to do is just use that shorthand for pandas, which we created with the as, which is PD. And then you put a capital S, and then you do series like this. And all you have to put inside is that list that we had, the random numbers. So if you do random numbers like this, you'll now end up with no longer a list of random numbers, but a pandas series of random numbers. And the way that we can see that is by using a very nice function in Python, which is built in. It's called the type function. So we can say, use the type function to see what structure random series is. All right, so over here, we're just going to say type and random series, just like this. So now, if you go ahead and run this, you'll see it says pandas.core.series.series. So you might be wondering, behind the scenes, what exactly is this, right? Like, why does it have this type of pandas.core.series.series? Like, even though we said pd.series, it seems to be just be a method, right? It's just a method that you can apply an argument into, and you might be able to view something, but the actual type, right, has changed. Because what was random numbers, right? So we can also do a quick compare and contrast. So you can say use the type function to see what random numbers is. So we can say type and just do random numbers. And one thing I just want to quickly mention is that if you don't have any print statements inside this block, then it only gives you the output of the final line of code in this block. So if you want to see both side by side, we need to put a print around this type for the series. So I just want to make sure that you're all familiar with that. Yeah. So now if you do this, you can now see that the first one says that it's a class, pandas.core series, and you can see that random numbers was a list. Okay, and let's see. Yes, I was just getting to that, but thank you for mentioning that, Koli. So that is absolutely correct. So series is actually what we call, as Koli mentioned, it happens to be a class which is built into the pandas library. In fact, pandas has two main classes. One of them, as we just saw, is series. And another one that we'll be seeing shortly is called the data frame. So these are two classes that belong to pandas. And what we're doing here, where we're creating an object where we use that class and you're passing in some input to initialize what we call as the object. So when we're doing that, we are essentially creating this class, and the object is of the type of that class. So that's why instead of seeing like a list, you actually see a pandas core series.series. So that's what that indicates. And for anyone who's not familiar with the concept of object-oriented programming, feel free to write a few questions down, maybe in the Discord chat, and I'd be happy to answer those questions. I even teach a few workshops on object-oriented programming, so We can also create our own custom classes and things like that. So you don't have to feel afraid of those concepts. Okay, so now that we discussed that, and thanks, Cully, for bringing that up, because it's a very important piece of knowledge. So the next thing that we're going to do is we're now going to upload a data set from a website called kaggle.com. Kaggle.com, by the way, is a very nice resource in the sense where it's like data science, but in a competitive way. So you have different companies that host competitions where they give you a data set and they give you an objective, and you could submit some kind of analysis or maybe even like a machine learning solution to that problem, either individually or in teams. And overall, it's a nice way to gain more experience with real life data sets, curated by companies, of course. But another cool thing about Kaggle is the idea that it's also a storage facility for data sets. In fact, there's an active community there which uploads data on a regular basis. And so we can leverage that to our needs, where we can download a data set and be able to upload it into Google Colab. So that's precisely what we're going to be doing. So in order to set that up for us, let's create another code cell below this. And what we're going to do is we are going to just say upload dataset into Colab. So in order to do this, we have to use a special module that's available only within Google Colab. In fact, it's a custom module that was created by Google in order to upload things and also to connect to like your Google Drive and things like that. So in our case, it's a very simple thing. We just have to say from google.colab. We just need to import a method called files, just like this. And so within files, we have a couple of methods that are available to us. One of those methods is called upload. And that's what's going to allow us to drag data sets directly into Colab and have them available to us. So we'll do that in just a second. We need to first get the data set. So what I'm going to do is on a different browser tab, I'm just going to go to kaggle.com. And within kaggle.com, I'm going to go to this search bar up here, and I'm going to type in a data set called celebrity debts. And you'll see this first data set here, celebrity debts. It's 4 years ago. This is the one that we should be using. So I'm just going to provide this link to everyone inside the Zoom chat. All right, and the way to download it is if you scroll down, you'll see this part over here where it says celebrity debts for.csv. It has 2.05 megabytes. So you'll see that there's a download button on the right side of it. So go ahead and click that, and it will download a zip file of this data set. So once you have downloaded the zip file, you can just open it. So you basically unzip it. So if you're in Windows, you can just extract the contents of it. If you're using a Mac, you can just click on it and it will automatically unzip it for you. Once you do that, you'll see in your downloads, you have a data set that looks like this, celebrity debts for CSV. All right. So now that we have that, all we need to do is within our notebook, the Pandas I, right in this cell where we did from Google Colab import files, we're just going to say files.upload, just like this. And now all we have to do is just click this play button, and you'll see that you get an interface like this where it says choose files, and right now it says no file chosen. So what you're going to do is you're going to click on choose files. And if you go to your downloads folder, that's most likely where it is. You'll see the data set. It's called celebrity debts for.csv. Just go ahead and just select that. and it will now be up in the process of uploading into our computer on Collab. Well, not our computer, but the computer given to us by Google. So you'll see that it looks like this, where you get like this dictionary like thing where it tells you the key is the dataset name, and it tells you all the columns that are being parsed into the dataset, in this binary string here in Python. So that's how you know that it's uploaded successfully. Another way to verify that, by the way, is if you do a plus code. You might be wondering, well, where are all these stored, right? Sure, we uploaded this data set, but where is it? So I think that's a fantastic question. And usually a lot of people miss this step in Google Colab, but I just wanted to make sure that you all understand how the file system works. So basically, we have to come to grips with the fact that we're not using our own computer. We're using a computer that is given to us by Google. So that means that Google has its own file system, which we can interact with. So I'll quickly show you that. So there are a couple of shell commands or bash commands that we can use in order to look at these things. So if you just type in the word ls, this is a command in bash that allows us to see all the contents in our current working directory. So let's say you just go ahead and run this. You'll see you have two different things here. First thing is what we just uploaded, which is the celebrity deaths dataset. And there's also another folder called sample data. So in fact, there's really more than this. It's not that we're only interacting with just these two. There's an entire Linux computer. So you have a bunch of different Linux folders in this cloud computer. So the way you can see all of that is by using a couple of bash commands. So one of them is very popular across all different shell technologies, which is called the change directory command, or CD. So if you do CD, you can reference directories that are coming after this path, or maybe even before it. So the way you can do that is, if you want to go backwards, you can just put 2 periods, just like this. And it will take you one directory backwards. And now you'll see that Google Colab mentions just a /. So what this indicates is that you are inside the root location on the computer. And the way you can verify that is by just doing an ls. And check that out. If any of you are familiar with Linux, you will probably see something like this. You'll probably see something like this if you are familiar with Linux. Yeah. And so, yeah, I just wanted to mention that, within these folders here, you'll see that another folder is called content. So this content folder is actually where we were. So the way you can do that is you can do cd content, just like this. And this will take you back to where we were before. So if you do ls, you'll now see that we have the data set as well as the folder. I just wanted to make sure that all of you are familiar with this file system, so you don't get confused in case when you're trying to import the data, it says it can't find it or something like that. Then this would help you to debug why. So that's what I wanted to show you there. So now that we have gotten the data set uploaded, I just want to make sure that's true, by the way. Did everyone get this data set uploaded? Great, fantastic. Okay, so now that we have that, we are now ready. Do terminal commands like this run in a regular Python file? That's a fantastic question, Cully. So in fact, if you just put it in a Python file itself, it probably would not work. It's actually really interesting because these code cells, they're not like the typical Python IDLE. In fact, they're not really a Python console. Like you can still put Python code there as well as like shell commands, but they're like separate routines within the cell. Whereas if you did this on your computer by just typing in Python and tried writing shell commands there, it would say that they don't exist because it's only looking for valid Python there. However, if you did want to write these commands in a Python file, the way that you could set it up is by using something known as the OS module. So the OS module in Python is actually like a way to interact with the file system. So it allows you to use these kinds of commands there. Great question, though. I'm glad that you asked that. Okay. So now that we got all of that mentioned, let's go ahead and go into the bread and butter of this session, which is really going into pandas. But all of these things are necessary in order for us to make sure that the pandas that we interact with today makes a lot of sense to you when you want to try it on your own. Okay, so now that we have done this part, we are now ready to start working with the module. So the first thing we're going to do is we're going to import this data set into pandas. So the way that we do that is by using something called the read function. In fact, this is a common word or terminology which is used in a lot of different languages. So if you have used like R or MATLAB or JavaScript, and if you've ever done any kind of like file input output with it, you've probably seen the word read somewhere in that pipeline. So like maybe in JavaScript, if you're using the node module fs, you might have heard of fs.readFileSync. Or if you use R, then R has its own read function for different formats like CSV and TBL, things like that. So in Python, we use pandas in order to get that read functionality. And pandas supports a lot of different data formats, most popular being Excel and CSV. But we also have other ones, like if anyone has used SPSS before, then you can also read data sets coming from SPSS. And you can also read JSON, so JavaScript object notation. So that's really popular for those of you who work in like web development or have worked with APIs before. Then that's like a pretty common format to read things in. So pandas supports all these different formats. And so the one that we're going to be interfacing with today is the CSV, since our data set is a CSV. Now, one thing I want to mention here is that the reading of CSVs, they follow something called an encoding. So whenever you actually read a file, the file has to be understood by the file system using some kind of map. So let's say that you're creating something that is only there in the US. Like if you're trying to read something that's only centric to or domestic, right, to the United States, then you can expect that everything that is there in the contents of the file will be understood by most computers that are there in the US. However, what if your data set was international and you had different characters that are coming in different languages, like for example, German characters or Russian characters, and maybe in Asia, you might have like different Asian characters, right? From China, Korea, even from India. So when you have that kind of an international data set, just having the standard encoding for files that we usually interface with in the US are not enough. And so I want to demonstrate that concept to you with this following error when I try to read the CSV. So I'm going to create a variable called df. And in most tutorials in pandas, they always use this. And the reason that they use the word df is because df stands for data frame. So we're actually not only importing data into pandas, but we're creating that second structure, which I was telling you that we'll be talking about, which is called the data frame. So maybe before we continue with that line of code, let's go back to our sketchpad for a second. The data frame, all you have to remember about the data frame is it's essentially that two-dimensional table structure. It doesn't have to be the whole table. It could also be two of these columns, and you would still have a data frame because it's two-dimensional. Anything that's one-dimensional, either vertically or horizontally, that is a series. And a data frame is anything that is two-dimensional. So you have this one series here. In fact, you could also force pandas to turn this into a data frame, but it doesn't really make sense to do that because it would just be a series. So you could do that. And then if you put two of them together, now you have a data frame. And then these three are a data frame and the whole thing is a data frame. So that's how you should remember the difference between a series and a data frame. So when you are reading the CSV, you are going to be getting a data frame as an output. So let's go ahead and try this out. We will get an error, but I'll explain why. So let's just say pd.read_CSV. This is the way that we can read a CSV file. And one of the cool things about Collab is it also gives you like a documentation to see like what are the different things you can pass inside of it. So all of that is possible. So over here, when we're saying pd.read_CSV, we're going to be reading a CSV file. And all we need to do now is provide the location to our CSV file. And it also says something here where it says file path or buffer. So you might be wondering, what is a buffer? So let's say that your file is not on your computer. Let's say that it's actually hosted somewhere else, maybe on the cloud somewhere. If you have a direct link to that CSV file on the browser, then that direct link, that HTTP URL that takes you all the way to the CSV file, you can actually copy that link as a string and be able to read it directly into Pandas. Now that's pretty cool, right? Because usually you would think that you're limited to just uploading data from your computer. But with Pandas, that's not true. You can actually import data which is not from your computer. So that's what they mean by buffer. In this case, since we uploaded the data set, we are going to use the file path. But I did want to mention that if you did have like a browser location for a data set, you could easily just paste that link. All right. So now that we've gone over this, let's go ahead and just put a string in here. And all you have to do is just pass in the name of the CSV file. So you can just say celebrity debts4.csv. Now, if you do it like this is normally how we would do an import, but we will get an error when we run this. And the reason being is because this data set for the celebrity debts is not a domestic data set. It is an international data set. So there are actually characters within this data set that do not belong to the traditional UTF-8 format. So let me demonstrate that. Let's say I go ahead and run this. We're going to get an error that says UTF-8 codec cannot decode byte 0 by 89 in position 28, invalid start byte. So this invalid start byte is basically saying that there might be a character that's in the German language, or maybe in one of those Asian languages that UTF-8 just doesn't know how to understand. So because of that, what we need to do is we need to change the default encoding of Pandas in order to understand the international format. And luckily for us, there is a standard encoding for international text. That is called the ISO encoding. So in order to solve this problem, all we need to do is just mention in Google ISO encoding Pandas. And if you type that in the search, you'll see that there's actually a Stack Overflow with this common error. And if you look at one of the answers in the preview of this, it says ISO 88591. So this is the exact standard encoding which is used for international text. So all we need to do is copy that encoding name. And I'm just going to pass this inside the Zoom chat so you don't have to look at this. All right, and make sure you put this inside of a string. Okay, we're going to write it together, of course, but just make sure that you do that. Okay, so what we're going to do is right after we put in the name of this file. Okay, I see in the chat. Does it matter that the data set is still zipped? Do we need to unzip the file, or can Pandas automatically do that for us? Great question. So since it is still zipped, Pandas will not know how to unzip it because what it's essentially doing is it's trying to look at the exact file name, right? So when it's zipped, it's actually not a CSV, right? It's actually reading a .zip. So since it reads a .zip, it's going to say that, this encoding doesn't understand what the zip is, right? So we do have to unzip it. So if you're using Collab and you uploaded the zip, if you want to unzip the file, it's a very easy way to do that. All you have to do is, let's say right above this ls that we have here, you can just put the plus code. And if it happens to just be called like celebrity debts like 4.zip, you could just do this thing where it says unzip, just like this. And all you have to do is provide just the name of the file. But if you want a really nice shortcut that allows you to unzip all the zip folders, you could just put an asterisk. And if you run it, it will go ahead and unzip that folder. So you just get the CSV. Sorry, did that answer your question? I wasn't sure if you're using Collab, so. Awesome. Excellent. Okay, so now that we took care of that, all you need to do after that is when we read the CSV, instead of only putting the file name, we also have to mention the encoding. So we can just say encoding equals, and all we need to do now is within the string, you just paste that ISO 88591 that I gave you in the chat. Oh, it's giving you a syntax error. 1 second, before we continue that, let me just double check that. I might be, yes, okay. So actually, I think what we have to do is we have to put an exclamation mark in the front. So that's kind of a weird thing, but let's just try that. Let's see. Yeah, so it works, it works. It's just that because I don't have a zip folder, it's just being confused. But yeah, I think that works. Can you just let me know if that works? If not, maybe we have to also put the asterisk in a string. But okay, very nice, very nice. Okay, good. Yeah. All right, so now that part is done. Yeah, so now you'll see that if we rerun this code here with this new encoding, we should be able to get the data frame. So let's say we go ahead and rerun this. You'll now see that we don't get any error messages, right? It looks like it's fine because we just put it as a variable, so we wouldn't expect any output. So just let me know if everyone's on the same page as me on this part. Excellent. All right, Howard and Kathy, you're both good? Okay. All right, so Howard either disconnected or left. But okay, so Kathy, I'm going to assume that you're doing okay here. And in case you get stuck on anything, I'm also recording this session, so you can also catch up on previous steps. I'll be uploading all these things to the Discord, so just make sure that you are a part of it. Let me just quickly see the general. Very nice. So you did join it. So that's great. So you'll see all of this recording stuff under Meetup recordings. And that's also where I'll upload the GitHub repository with all the code. So in case if you get stuck at any moment, you can use that to your advantage. All right. So now let's go ahead and continue. So now that we have read this data set, the next thing that we need to do is we need to look at some ways to preview the data. So I'm going to put a hashtag here that says preview the data. And the first thing that I'm going to do is put two hashtags, and I'm going to say see the first 5 rows. So the way we can do this is to say df, and the name of the method is called head, just like this. All right. And then if we just press play, you can see over here that it says age, birth year, cause of death, death month, death year, famous for, name, nationality, and fame score. So as you can see here, we are able to see the first 5 rows of all the different columns that we have. And you can see that the column names are bolded and the rows just have like the normal typeface. But as you can see, even on this first one, right, with Frank Carey here, you can see under where it says famous for, you can see that the U and the O have like that special character, right? So that's already a reason as to why the standard encoding wouldn't work, because these are not supported by UTF-8. I know it is a little depressing in the sense that these celebrities are dead, but it's a very interesting data set too, because there's a lot of great insights you can get from this, because it's international, right? It's not just limited to Americans. So that's what makes it really interesting. But anyways, so yeah, so we are able to see the first 5 rows by using this df.head. Now, let's say if we wanted to put 2 hashtags and say, see the last 5 rows, we can say df.tail. And we can just go ahead and press the play button there. And you can see over here that we can see the last 5 rows by doing that. Now, you might be wondering, are we only limited to just the number 5? In fact, that's actually not the case. We could change that number to be as many rows as you want. It's just by default, Pandas sets it to the number 5. So let's say if you want to see the first 100, all you have to do is, let's say in the head method, you can just put the number 100 in there. And if you do that, that would give you the first 100 rows. I'm not going to run it, of course, because it would be a little bit of memory consumption on this. So I'll just keep it like this for now, but I just want to let you know that that's possible, that if you wanted to put a different number, you could easily do that. So maybe let's say for tail, if I put 10, so we can see the last 10 rows. So now it looks like this. So that gives you the idea. Okay, so let's actually change this to 10 rows. Okay, and then besides this, you might be wondering, I did mention before, right, that this is a specific type, right? So the specific data type would be a series, right? Sorry, wrong, data frame. This is a data frame. So in order to see that, we can just say view the type of the imported data set in Pandas. So the way we can do that is we can just say type and just put df in there. And if you run it, it'll tell you that it's a pandas.core.frame.dataframe. So this is a data frame. All right, and that's pretty obvious, right? Because the way that I explained it to you was that it's 2-dimensional, right? It has rows and it has multiple columns. So that's how you know that it's a data frame. Now, of course, we don't have to be limited to just that one structure. You could also filter on specific columns. So the way you do that is actually really easy. Let's say if you wanted to get a list of all your columns. So creating a list of all data frame columns. So to do that, we can just say df.columns. And if you put it like this, you're going to get what we call as an index. So if you run it, it's going to tell you that this is an index, which is another object within pandas. And it's basically like, you can think of it as a list, but it's like, it's more of like a different class than just a list. It's something that you can convert into a list, but by default, it's not a list. But as you can see, you can still see all the different columns in this way. But let's say if you wanted to convert this into a list, then all you have to do is just say dot to list, just like that. And if you go ahead and run this, you'll get an actual Python list with all the different column names separated by commas here, just a normal list, and they're all strings, right? They're all strings here. So that's what this indicates. And it's very easy to index as well. So for example, what if you only wanted your data frame to only have the first 4 columns? So we could actually slice this list and only get the first 4. But what I'll do here is I'll create a variable for this called data calls, just like this. And now we're actually saving this list as a variable. So now if I want to filter the data frame to only contain a slice of the data columns, then all you have to do is just say df, and just as if you're using a dictionary, just go ahead and pass in these square brackets here. And inside the square brackets, you just have to pass in the list of column names. So if I say data calls, let's say that I slice this list. I put another square bracket in there. And if I want the first 4, then all I have to do is just mention the number 4 here. Now, one thing you'll remember about slicing in Python is that what I'm actually putting there is not just the regular number 4. It actually happens to be the index, the 4th index in this list. But the reason why I put the number 4 there is because the 4th index is not included in the slice if it's coming after the colon. It is everything up to 1 less than that number. So that means 0, 1, 2, and 3. So it's still 4 columns. So let's say I do this, and you get all the rows and 4 columns. So you can see age, birth year, cause of death, death month. So that's what this indicates. And of course, it's very easy to get more or less, right? You can just change the index to whatever you like. If you wanted to start from birth year, you can put like the number 1 here. And then you would get birth year, cause of death, and death month. Just like that. All right, so I hope that's clear, like how the filtering works and how to convert the columns into a list. So does anyone have any questions so far, or are we ready to move on? Good so far? Excellent. All right. So now that we have that part out of the way, let's go ahead and look at how does the series connect to the data frame in this case. So the way that we set that up is we would say df, and let's say in this case, you're only interested in a specific column. Let's say in this case, the age. If you just do df and age like this, so we can just say selecting a column. And we'll just say, oops, yeah, right here, 2 hashtags. And we'll just say pass in a column name as a string into the data frame, just like this. So if you run this, you'll get something that looks like this. You'll see on the left side, you have all these indices. It starts at 0 all the way to the number of elements, the number of records, the rows, -1. So the last index would be 1 less than the overall number of rows. We can see that. We can also see the name of this column, and you can also see its data type here, which is integer 64. All right, so all of this is shown here. And what you're seeing on the right side happens to be the actual values that each of these indices hold. So that means if that first record was for Frank Carey, then Frank Carey died at the age of, or 85, or maybe, yeah, that's probably what that means. Like he died at 85. And then whoever was there in second was like 49 or whatever. But yeah, you get the idea, right? That the right side of this shows you the values. The left side is the index. You can see the meta information here, that the column is called age, has this many rows, and you can also see its data type. So this is all very, very useful information. So you might be wondering, like this int 64, like, you probably don't regularly see that in Python. Usually it's just, like int or float. So this int 64 is actually using a format that's coming from C, like the C language, like where Python is like using a module called numpy in order to extend the functionality of C into Python to use these data types. So that way you can get more organized data types in order to handle the different data that you might have. So that's really what's happening there behind the scenes. So in case you're wondering why it's not just called int. So that's what that indicates. However, if you did want to filter on a specific value, it would be interesting to see what that type is. So let's actually try that. Let's say that within age here, what if you wanted to just get that first 85? So there's a nice way to do that. In fact, we can just say index a row in pandas. So I'll show you how you can do the normal indexing of a row, and then I'll show you how we can get that single value from the series. Oh, I forgot to mention that we know that what we just did with df age is actually a series, right? We can actually verify that. So we can just say type and just say df age, just like this. And if you run it, it'll tell you that it's a series. And that makes sense, right? Because you're only looking at one column. So in that one column, all you have is the dimension, which is all the rows. So it's no longer two-dimensional, right? It's one-dimensional. So that's why it's a series. So does that part make sense? Like you understand how the data frame and series are connected now in pandas? Do I have a yes there? Excellent. All right. So the next thing that we have to do here is when we're doing the indexing, there are two functions that we can use, or two methods actually in pandas that can help us to do this. So one of them is called lock, and the other one is called ilock. So the one that we're going to be using is called ilock. So for ilock, all we have to do is just say df age, or actually no, instead of doing df age, let's just do the data frame, and then we'll say .ilock, and inside these square brackets, you can mention a specific index as if you're indexing like a list. Then you can just put a number that you want to see. So let's say you put the number 0, then this should give you the first row in the data set. So if you go ahead and run this, you'll get something that looks like this, where you can see the names of the columns on the left, and you could see all the different values on the right. So if it's not clear yet, what do you think this is? What structure in pandas do you think this is?
Is it a series?
That is correct. And the reason is because we're only looking at a single row. So all the columns are values that are part of that row, but it's one-dimensional because you're only looking at that single row. So that is why this is a series. And in case anyone's uncertain about that, we can always look at its type. There you go. So now you understand that series is not just the columns. It could also be the individual rows. So now that we have understood that, the next thing we might be wondering is, what if inside the series, you wanted to get a specific column? Now, one thing that's really cool about series objects is that you can index them based on this value that you see on the left. So this value that you see on the left is actually called the index. So let's say if you wanted to get a list of all these different indices here, there's a very easy way to do that with a series object. So let's actually set this as a variable. Let's call this as row 1. Oops, just like that. And in the next block, I'm going to say creating a list of the series index. So to do this, all we have to do is just say row 1 dot, and let's say you just put in this attribute called index, just like that. Let's say you go ahead and just run this. You're going to get this index object again, and look what's inside of it. You have all these different column names that we have for that row. And remember what we did before with the columns when we did dot columns. If you want to convert it into a list, all you have to do is just say dot to list. And you get a list of all the columns. As you can see, even within a series is made up of an index as well as the values. And it's one-dimensional in the sense where when you view it, you're viewing the values, but you also have a corresponding index which can be used to get specific values. It's a very neat data structure, right? Like, it's just so easy to be able to get the information that you want, as long as you put it in that way. And so one of the really cool things about this is, besides just getting the list of the index, we can also use the index in order to get a specific value. And I'm going to show you that now, where we can just say in 2 hashtags here, getting a specific value using the index. So that's very easy. You just say row 1, which is already giving us the first row. And all you have to do is just mention which particular index do you want the value for, or which value do you want, like which index are you passing in to get a specific value. So to do that, let's say you want to do this for the age, right? So in row 1, you're interested in the age of that person. So you can just pass in age like this. And when you do that, you're going to get 85. It's going to give you the corresponding value to that. So a way you could think about the way that the index works here is very much like how a dictionary works in Python, where the series itself could actually be like a dictionary in a way, but it's also like a list where you could also get things, based on these values of 0 to whatever it is. But if your index is not a number, then it works just like a dictionary does, where you can just pass in the string for that index, which is like the key in the dictionary, and the value would be the corresponding value. So in age, we know that it was storing 85 for Frank Carey. So that's why we're getting 85. Now, we did see that in the series, the data type was int64. So one thing we could look at here is, what if you just put type around this value? Would it still be int64, or would it actually just be an integer? Let's find out. So it actually tells you that it's coming from numpy. So what did I tell you before? NumPy is using the C language to extend to Python these additional data types. So this is direct evidence that NumPy is doing that. And you can see the exact data type for this particular value. We would all think that it's an integer, but it's actually a 64-bit integer, which is coming from NumPy. What do you think about that investigation? That's pretty cool, right?
Does vanilla Python somewhere like deep under the hood use
Absolutely.
stuff like int64?
Yes, absolutely. In fact, the numpy module, it's actually using vanilla Python for quite a few things, like in order to like wrap all these different structures together. And same with pandas. But in order to get this additional functionality, we're actually extending Python, where Python now has access to some of the functionalities of C. There's a specific module for that. It's called C Python. So Python can now interact with like the microprocessor level operations of C. And so that's where we're able to get all these things. But yeah, like it's a mixture of vanilla Python as well as C Python. Like it's not just like one or the other. And there are a couple of methods like within NumPy which demonstrate that. There's like a lot of the package is built on C Python, but there are some parts that are built in vanilla Python as well. So I hope that answers your question.
Yeah.
All right. So now that we managed to investigate that, you now know how to get a single value, you know how to get a row, you know how to get a column, and you know how to filter the data frame into a smaller data frame with the columns that you're curious about. So you already learned a lot. But there is still some more things we can do. Like we're just scratching the surface here. So just out of curiosity, how are you all doing in terms of time? Do you think we could spend another 15 minutes or so? Okay, good. All right, Kathy, is that okay? All right. I'm assuming that it's okay. Okay. So let's go ahead and wrap this up in the next 15 minutes. So now that we saw all this information, let's say that for a specific series, you wanted to get some more insights. So let's say that we're interested in nationality. So gaining some insights on the nationality column. So what are some things we can do? Well, for example, what if we wanted to find out how many American celebrities are there in this data set? So there's a very nice way we could do that. So all we have to do is get our data frame, and we have to get the column that we're curious about, which is nationality. So we're just going to say nationality. And in there, now you have a series, right? You have a series with all the values and the indices for nationality. So there are a couple of methods that series objects have in pandas, which can help us with this task. One really good method is called value counts. So it creates like a frequency for each unique value. How many times does it appear? So let's say you do dot value counts, just like this. If you go ahead and run this, you'll now see that you get another series that looks like this, where you have the column, not column names, but the actual values, right? So like if some of the records are American, some might be British, some might be Canadian. So all those values are being counted, and each of those unique values are being represented as an index. And you can see the number of times it appears in the data set as the value. So that's what this is indicating. So if you only wanted to get American from this, then all you have to do is just index it just like a dictionary with American. And if you do that, you're going to get this number of 8,028. So that's how you can find all the American celebrities, or the number of American celebrities. Number of American celebrities in the data set. Yeah, absolutely. Graphing, there are a couple of graphs that are available in Pandas, but I'm going to be saving that as a part of a visualization workshop. So we can create the graphs and stuff in that workshop, but I'll make sure that that happens soon, maybe in the next like 2-3 weeks or so. But yes, you're absolutely right. It would be nice to have those visual analytics as well. All right, so now that we saw how easy it was to get the number of Americans in this data set, there are some other things we could do. Like, for example, let's say that for the age column, you wanted to know what is the average age, and also maybe like the standard deviation of the age, some descriptive statistics, basically. So if we want to do some descriptive statistics, then there are some nice ways to do that in Pandas. So let's say that you want to do this just for the age column. So you could just say df age, and all you have to do is use a method called describe. And when you do this, this will give you a series where the columns are the different measures of descriptive statistics, and the values would be their corresponding values. So if you run this, you'll see something like this, where the first thing is the count, how many records there are, the average of that column, the standard deviation, the minimum value. You can see that there is a 25%, the 25% mark there, quartile. The 50% would be the median, 75% is like the third quartile, and then max would be the maximum value. So you can get all these different measures in just that one line of code. And if you wanted to get only one of these things, like the average age, you could just index it with the mean. There's also another way you could do it, where instead of just saying describe, some of these descriptive statistics have their own methods with series. So for example, so if you just were to say mean, right, you can get the average age of this column. So you can say getting the average age. So you can just pass this in, and it will just return that 76 number there. Yeah, and then right above this, okay, so Coley, you raised your hand. What's up?
Yeah, just a quick question. So df square brackets age, that gives you back a series, right?
Yes, it gives you a
So-
series for the age column.
Yeah, okay. So are like dot mean and dot describe and other things like that, is that something you can use on basically any series?
Oh, great question. So for descriptive statistics, the fundamental assumption that we have for it is that it's numerical, right? Because if you don't have numbers, then we can't calculate these things. So
I tried to dot describe on cause of death, and it gave me like different statistics like count, how many unique, top cause, top whatever. So that seems to have a different behavior for a list of or a series of
right,
string.
but it didn't give you like a mean or those
Right.
things, right?
Okay.
Yeah. So for descriptive statistics, I guess Pandas has also improved a lot recently. So maybe they're doing some like text-based analytics now too, which makes sense. But it wouldn't be a descriptive statistic, right? It would be something related to the characteristics of the text in that column. But if you're only looking at descriptive statistics, then it has to be numerical.
Okay. But these methods are series methods, right? It doesn't have anything to do with the fact that it came from a data frame originally.
Oh, good question. So we could use describe on a data frame, but I don't believe we could use these individual statistics methods on those, because it wouldn't. Well, actually, let's try it. It's better to try it, right? I mean, they might return it perhaps. Like maybe you could have like a series, like where it gives you each column and then it returns the mean. I think that's feasible, but let's see if that's what it does. Oh yeah. So as I mentioned, looks like that actually did work. Okay, cool. And then if you describe, then that makes more sense, right? Because it would give you a data frame where you have all of these different values, right? The mean, the count, all of these would be like the index, and then your columns would be the individual columns, right, from your data frame. So you could just say describe just like this, and it would look like this. So you could use it directly on the data frame, but as you can see here, it's showing it for age, birth year, death year, and the fame score, right? It's not showing it for cause of death, because you can only get these descriptive statistics on numerical columns. And so these are the only numerical columns that are available to us.
That makes sense. Thanks.
Yeah. And yeah, so, and we did see actually that that's actually pretty nice that they made that. This must be the recent version of Pandas, because before that wasn't possible. But that's really cool, where if you just put like df.mean, it does give you a series where each column would be the index and the mean would be the value. So that's really neat. Yeah, it's looks like we're all learning something new. So that's nice. All right. So yeah, so we can see how easy it is to get the descriptive statistics. So I'll just say getting all the stats for all numerical columns. Okay, so now that we have gotten that part out of the way, we've seen how easy it is to get a specific statistic like the mean, and also like the min, the max, all those things. You could just replace mean with those things and it would work. So that's good. So now that we managed to get that, let's see, what else is there that we haven't done yet? Yes, now let's look at queries. So I'm sure if any of you have worked with SQL in the past, then you've probably written like a SQL query to get specific information. So we can also do something similar with pandas. So let's actually conclude with that, because that's a very important step that will help us for the next session. So let's actually do that. So we're going to say writing a pandas query. So a pandas query is nothing more than just what you have already learned, but there's a little bit more information there, where you're using a logical operation to get specific information. So what do I mean by a logical operation? I mean things like a value is equal to something, or a value is not equal to something, a value is greater than a number, less than a number, maybe greater than or equal to, less than or equal to. That's what I mean by a logical operation. So in this case, we can apply logical operations to pandas data frames as well as series objects. So in this case, let's test it out on a data frame, where what if you just wanted to get the birth year and death year for celebrities who are older than 60? Let's say that was what you're interested in. And there's a nice way to do that using pandas. So I'll just say getting the birth year and death year of celebrities who are older than 60. So to do this, we start with trying to get all the celebrities who are older than 60. So the way you can do that is you first mention the data frame, and inside of the square brackets, what we're going to do now is we need to pass in a series. We have to pass in a series that we're curious about. In this case, the series that we want happens to be the age. So you can say df_age just like this. And if you want to say that it has to be older than 60, you can use this logical operator of the greater than symbol and now pass in the number 60. And if you do this, you're going to get an entire data frame for all the values that are greater than 60 on the age column. Let's say you run this, and that's precisely what you're going to get. You have 18,217 celebrities who are older than the age of 60 in this data set. So that's what this does here. But now, remember, we didn't only just want this, right? We also wanted the birth year and the death year. So what we have done right here, by just passing in this control into the data frame, we have created another data frame, a data frame that uses this logic to get specific information. So now that we managed to get that, all we have to do now is essentially only select these two columns, birth year and death year. So to do that, we can just put another set of braces here. And in here, you would just pass in a list. So it could be birth year and death year. So if you wanted to make it a little bit easier to write, you could create a variable right above this and call it calls to keep. And in your list, you can just put birth year and death year. And now that you have this, all you have to do is just put calls to keep inside the square bracket. Just like that. And now if you run this again, you'll now get just those two columns with the same rows that are for all the people who are above the age of 60. So what do you think about querying in Pandas? Pretty straightforward?
Seems really powerful.
Yes, it is very powerful. And there are some more advanced queries we could do. Like, for example, you might be interested in, how do you do like an and or an or operation where you have multiple conditions? We could do that in Pandas as well, but I'm going to save that for the next workshop. Today, we're going to go with the simple operations. And I guess before we go, there are just two more really nice operations to know about, or actually three more. Let's say you're interested in sorting. Like you want to sort by greatest to least or something like that.
Can I ask a quick question about querying?
Yeah, what's up?
Inside the first square brackets, you have df age greater than 60.
Yes.
Does that statement right there, that returns like some series or list of just Boolean values, or is that how that works?
You're absolutely right. That's exactly right. So what's going on is that anywhere where that condition happens to be true, those indices are now being applied to the data frame. Because remember, whenever you look at the data frame, what's the first thing that you see? You see all these different numbers for the rows, right? So each of these numbers for the rows, the index, is mapped to a Boolean series, where the Boolean series is sharing the same index. So we're just basically getting a collection of indices that are helping us in order to only get that specific information where it happens to be true instead of false.
So if we were to like just manually create a list of trues and false or something, we passed in that list instead of that statement right there, we'd get like a similar behavior.
Correct. Yeah. In fact, we can see that, right? Let's say if we go over here, let's just run a code cell down here where all we're going to do is just say df age is greater than 60. And you'll see that you get a bunch of true falses like this. So all those indices where it says true, all of those are going to be indexed to the main data frame, and it's only going to return those rows.
Awesome. Thanks.
Yeah. Great questions. I'm glad that you're asking all this. All right. So now that we managed to do that, yeah, so the next thing we can do here is, what if you wanted to do some kind of sorting operation where you want to sort the values by a specific column? Let's say you want to sort it by the maybe the birth year, right? Let's say you want to do something like that. So we could say over here, sort the data frame by a column. So you would just say df, and you can say sort values, just like this. And all you have to do is just, where it says by in this argument here, we just replace the by with the name of the column. It could also be based on multiple columns. But in this case, if you only want to sort it based on one, then you just have to pass in a string associated with the column name. So let's say that you want to do this by the birth year. You can just say birth year like this. And another thing is, right now it says by ascending, right? So what if you want to do descending? You can just say ascending is false, just like this. and let's just say over here, sorting the data frame by birth year in descending order. So let's say this is what you were trying to accomplish. Then if you run this, we will now see that new view of the data frame. So now it looks like this. So you still have the same number of rows and columns, but now if you look at the birth year, you're going to see it starts with the most recent birth, the celebrity at the most recent birth, and it's going downwards all the way to the lowest number you can find. So in terms of a year. So that's how you can do sorting in Pandas, by using sort values, passing the column name, and if you want ascending or descending, ascending is there by default. So to make it descending, you just pass this as false. And if you wanted to, let's say, remove duplicate values, you can do that too. So let's say over here, let's say you want to remove duplicate values in Pandas. We can just take the data frame name and we just do dot, and it's called drop duplicates, just like this. And in here, you can mention a subset of columns where you want to remove the duplicates from. But in this case, if you just want to remove duplicates that are there for the entire row, you can just leave it just like this. And if you run it, you'll now see that you get, let's see, the 21293. Is that the same number up here? No, this is different, right? So we actually did lose some rows, right? So there were a couple of duplicates in the data set, and we removed those rows. So that is another useful feature. And the last one I wanted to show you was, what if your value was missing? Can we remove those rows? Yes, we can. So drop missing values from the data set. So to do that, we can just say df dot, and the way that we represent missing values in Python is called NaN, or in other words, like not applicable. So that's how you know that it's like a missing value. And the data type of it, you'll actually be surprised by this. It's actually a float. It's a float that's coming from NumPy. So NumPy like passes in NaN as a string, but when you convert it into a float, it understands that it's a missing value. It's a pretty cool way to construct it. So now if you just say drop NA, we're not putting any parameters in there. So we're not looking at specific columns. We just want to see that anywhere in the data set, if there's a missing value, remove that row. That's what this does. So of course, you have to be very careful when you use this, because what if every single row had a missing value, right? Then it would remove all the rows. So you have to be very careful when you use this. So sometimes maybe you're just interested in a specific column that has missing information, right? Maybe it could be the cause of death is missing. So maybe you only want to remove records that have a missing cause of death. Maybe that's what you're curious about. In that case, maybe we could apply that here. So it says over here, cause of death, right? So we could say drop NA. And if you were to say, let's say subset, you can just pass in the name of the column in strings. So you can say cause of death. And let's see, if we do it like this, this should work. Sometimes we might have this error where it says like we need to change the axis or something. I'll explain what that is if we get the error, but I don't think we're going to get the error, but let's find out. Let's see. Okay, so yeah. Okay. And also one thing we have to be a little careful about with subset is we can't just put the string. We have to put a list of the columns. So you have to put a list around cause of death. Just like that. Yeah. And then if you run this again, there we go. Yeah. See, now you're getting 8,974 rows where you are aware of all the cause of deaths. That's what this indicates. Okay, so is that clear? Does that make sense? Okay, fantastic. The last thing I want to show you, this is a very simple operation, but it's like checking the the overall shape of the data frame. So basically by shape, what I'm trying to say is you're getting the number of both dimensions, how many rows, how many columns. So it's very easy to do that. You can just say df.shape, and it gives you a tuple in Python where the first number is the number of rows and the second number is the number of columns. So that's pretty much it. So this gives you like a nice overview of all the different things you can do with pandas, with querying, with looking at the shape, removing duplicates, sorting values, filtering, getting descriptive stats. So you learn plenty. So there's already a lot you can do. And you also got a nice tutorial on collab as well. You got to learn about the file system of collab and how to upload data, how to get to the data, understand the computer that you have available to you. You also learned about encodings, right? You learned that not every data set in the world can be understood by UTF-8. So sometimes you have to use other encodings. So I think you learned plenty. All right, so yeah, of course, we could go on all day on this because there's still a lot to learn, but I think you definitely have a nice primer on what's available to you within the Python ecosystem for data science, especially with pandas. So I'm glad that we had this. In the next session for this related series, I might have it available maybe in the next 2 weeks or so. That one is going to be a premium series, actually, because we're actually going to be connecting SQL databases and read different tables of SQL into pandas. That's what we're doing in that one. So for that one, it requires a premium subscription with ChanR-Community. If you're interested in subscribing, I can share an Eventbrite link with you where you can look at our different plans. We actually have 3. So there's Gold, Platinum, and Professional. In Gold, you get access to all these different series workshops, except for any end-to-end projects. In Platinum, you get access to a bunch of end-to-end projects that simulate real-world projects, and these projects would really like shape up your portfolio, especially if you're interested in software engineering or data science. Like these projects will really help you stand out because they're very much involved and they use a lot of technologies that you'll most likely be using in the workplace. And the third one is called the Professional plan, where you get access to both Gold and Platinum, and at the same time, you also get some insider information on how to stand out in an overcrowded job market. You'll get to, get personalized reviews like on any projects that you have. You'll get your portfolio optimized, edits on your resume, mock interviews, and things like that. So I have 3 different plans. If you're interested in seeing the pricing for that, I created an Eventbrite link, actually. I'm trying to move to an automated Stripe processing for it. So I'm still working on that. I haven't had enough time in the past 2 months to get to it yet. But most likely in the month of June or just July, like that's when I'll move to an automated subscription service. So then, you don't have to worry about getting an Eventbrite link from me. You could just enroll there using Stripe. But if you want to enroll like, in this month or next month, then I recommend the Eventbrite link. So let me just quickly pass that to you so you can look at our prices. And if you want to take some time to decide, like I'll still make like free workshops throughout the month. So it's not that you won't be missing too much. Like I'm just trying to keep a nice balance between what I offer to the overall community and what I offer to subscribers, because there's a lot of value that I generate in these workshops and a lot of knowledge that I can share. So I just want to make sure that it's equal to me just as much as it is to you in terms of the effort. So yeah, just give me 1 second. I'll just share that link with you. Okay, so in the Zoom chat, you'll see that. So you can see the pricing for the 3 different plans. So there's Gold, Platinum, and Professional. Yeah, that's pretty much it. So if you have any questions about those subscriptions, you can always reach out to me on the Discord channel. And I also offer discounts. So, if you want like a discount, like for like a 2-month or 3-month period, we can talk about that. And I'd be happy to accommodate those situations. So yeah, that's pretty much it. So, thanks, for spending this time with me to, go over pandas. I think we gained a lot of useful information today. And I will make this notebook available in the GitHub repository that I made for this workshop. I'll also add some additional notes and also some sketches that we created. So I'm going to take some time to do that. So I'll hopefully release this repository most likely in the next 2-3 days. But the recording will be available by the end of the day today. And you'll get all that information here in the Meetup recordings channel. Sound good?
Yeah, thank you so much. This was great. I'm looking forward to playing with this some more. I appreciate you taking the time to set this up.
Awesome. I'm really glad that the session was valuable to you. And nice meeting you, Coley, and also nice meeting you as well, Kathy. So definitely stay tuned. There's a lot of workshops coming, a lot of free ones and a lot of premium ones on a lot of different topics. Right now, I'm thinking of reviewing some of the topics I did before. So like things like developer operations, like Docker, Kubernetes, and I'll also discuss like GitHub and version control in depth as well. So in case you want to learn how to use those technologies at a professional level, then I can also teach you that. And of course, a lot of other workshops related to like web development, to data science, and overall just the whole landscape of tech as it stands. So it'll be step by step, but it's very broad. And in each topic, like I try to go into enough depth so then you can come out with a little more confidence than what you had before. So that's the idea. And yes, of course, if you do go for like some of these advanced plans, then you'll get a lot of value. You'll get to create projects that really help you stand out. Sometimes I even personalize them. So if you have like a project that you're interested in, I can try and make that as a workshop. I can teach it in different sections, and then we could turn it into a reality. So a lot of different opportunities there. So yeah, I'm excited. So I hope I'll get to see all of you again. And yeah, that's pretty much it. So, thanks so much again, and have a great rest of your day. Yep, you're very welcome. All right, take care.